Section 3.9 is where you're going to apply all of those special angle pairs to identify what your parallel lines are. So the converse of corresponding angles says that if two lines are cut by a transversal so that the corresponding angles are congruent, then these lines are parallel. This postulate 313, if given a line and a point not on the line, there's exactly one line that's going through the point and is parallel to it. This is something you don't really need to be worried about putting on your frame. But this first one with the converse of corresponding, along with these two guys here, alternate exterior angles converse. So if you have a pair of alternate exterior angles that are congruent, then you're going to know the lines are parallel. Same with alternate interior. If you have alternate interior angles congruent, then you've got two lines parallel. And then remember, consecutive interior has to be supplementary. So if you've got consecutive interior angles, such as 7 and 6 that are supplementary, you've got lines that are parallel. This last theorem, perpendicular transversal converse, just says that if two lines in a plane are perpendicular to the same line, for example, like this, line A is perpendicular to B and C, therefore B and C have to be parallel. Okay, so what we're going to do is we're going to identify if we have any lines that are parallel, and then we're going to state the postulate or theorem that we can use to justify our answer. So here's my picture down here at the bottom. You have to figure out 2 and 8, what kind of special angle pairs those are. So 2 and 8 are on the inside, I see, of these two lines, and they are alternating diagonally. So that means that 2 and 8 would be alternate interior angles. So the first thing is I would know I'm using that pair. So according to the alternate interior angles converse, you're going to know two lines are parallel. So what you want to do is find where your two angles are, just like we did the last time, highlight where those are, and then extend those lines. So if we highlight across here and across here, we're going to see that these are my two lines that are parallel. This would be my transversal cutting through it. So I would write that A is parallel to B, and I would know they are parallel because of the alternate interior angles converse. Now, if you don't want to write out that wording, yes, you can write out the number for it. So theorem 322. Okay, so on the next one, we've got 3 and 11. So 3 and 11 are corresponding angles because they are in the same spot of each cluster. So therefore, when I extend my lines out here, so I've got 3, I've got 11. So if I highlight where those are at, that means that I would have L and M parallel, and then A would be my transversal. So L and M would be parallel, and then corresponding angles converse if you're writing the name, or the number theorem 319. Pause the video and try letter C. So on letter C, you're going to notice that 12 and 14 are alternate exterior angles. So you would use the alternate exterior angles converse. Then you can come through and highlight where your angles are. So 12 is here, 14 is there. So when I highlight my lines that extend through there, I'm going to see that A and B are parallel with M acting as the transversal. So A and B will be your parallel lines. Pause the video and try the next check question. So in the next check question, it's asking you what postulate would allow you to say this. So if 1 is congruent to 15, those are not on the same transversal. So therefore, we would not be able to know anything about lines being parallel. So if it said that 1 was congruent to 11, that would work. 1 congruent to 9, that would work. But since it's all the way over here, those are not on the same transversal, so therefore we can't use it. On letter B, they said that 3 and 10 are supplementary. 3 and 10 would be consecutive interior angles. So I would say that, highlighting my lines here. So here's 10, here's 3. So I see that this is my transversal. These two would end up being my two parallel lines. So N is parallel to K. And then either theorem 321 or consecutive interior angles converse. Last one, 3 and 5. 3 and 5 are alternate interior angles because they're both on the inside and alternating diagonally. So here would be my transversal. L and M would end up being my parallel lines. So I would say letter A for your answer. What this also allows us to do is to find some angle measurements, and that's what we're going to take care of next. So it says find Y if you know that E is parallel to F. So an important thing that they show us from our picture is this is 90 degrees. And remember, if this is 90 degrees, we know all 4 of those angles have to be 90 degrees. We also know if these two are parallel, these two guys here are consecutive interior, and those have to be supplementary. Therefore, both of these are 90, which then concludes all 4 of these are 90. How is that helpful? Because that means that this angle right here has to be equal to 90 degrees. So I'm going to take my 4y plus 10 and set it equal to 90, and then I'm going to solve. So I'm going to minus 10, and then I'm going to divide by 4. Pause the video and try the check question. So in the check question, they tell us that M and N are going to be parallel. So I'm looking to see if M and N are parallel, what happens? These two guys end up being corresponding angles. And since they are corresponding angles, those have to be equal in order for these to be parallel. So therefore, I'm just going to set them equal to each other and solve. So I minused my 2x, added my 3, and then I divided. So I got x to be equal to 1, and then I named the theorem that allowed me to use it. So corresponding angles converse, or you can use again that theorem number, which would be theorem 319. Then on the next check question, it's a little bit more involved because here's the angle they're wanting me to find, clear down here. So they give me a lot of information. They give me these two angles labeled. They also give me these two. So there's really 2 different setups you could do. I know that these 2 angles form a linear pair, so I know those have to be adding to 180. Or I also know that these 2 are alternate exterior angles, so therefore they would have to be congruent. So you could set them equal. I decided to go that route. So I set 4x plus 6 equal to 9x minus 12. I then subtracted my 4x and added my 12, and then I divided. Now this question asked me to find the angle, not just the variable. So this is where you want to go back and plug it back into your expression for LMN and then solve it. So that's why the answer is 20.4. All right, just a couple more here. So in your picture, it was really hard to see where the lines were that they were talking about. So it says to move a straight line with maximum efficiency, rowers' oars should be parallel. Refer to the photo at the right. So here are the oars, and so I tried to highlight them in red so you could see them. This angle right here is 50 degrees, and this angle up here is 124. Is it possible to prove any of the oars are parallel? So what I did is I went ahead and found these angles. So if this is 50, that means this angle has to be 130 because those guys are a linear pair. Same thing over here. If this is 124, this guy would have to be 56 so that they are a linear pair. In order for these to be parallel, these 2 angles being consecutive interior angles would have to add to 180. Since they don't, so if I added 56 plus 130, since they don't add to 180, these lines would not be parallel. So I just wrote they're not parallel because of the consecutive interior angles are not supplementary. Pause the video and try the check question. Again, the picture was a little hard to read, so I highlighted over here in red where they actually were, and then these were the two angles that they were giving. They're asking if these two sides would end up being parallel. Again, no, because these consecutive interior angles have to be supplementary. All right, folks, so section 3.9 is where you're using all the converses of our special angle pair theorems to prove if you have lines that are parallel.